Yesterday we looked at exponential decay and exponential growth functions, and with exponential growth functions we also looked at normal interest rates and then also compounding those interest rates. And so we're going to review that a little bit here first and move into something new with it. So if you invest $1 at 100% interest rate for a year, how much will you have? Well, if you were setting this up, you would have $1 times 1 plus the percent, which is 100%, so 1 to the first power. And 1 plus 1 is 2, and 2 to the first is 2, times 1 is still 2. So after a year, you'd have $2. Well, now what happens if we take that and we compound that 100% interest rate? And we do it in all of these different ways: quarterly, monthly, daily, hourly, minutely, and secondly. Well, if we were to do this quarterly, we would have 1 times 1 plus 1 over 4 to the 4th power. For monthly, it would be 1 times 1 plus 1 over 12 to the 12th power. For daily, it would be 1 times 1 plus 1 over 365 to the 365 power. For hourly, it would be 1 plus 1 over 8,760 to the 8,760. You just take 365 times 24 hours in a day. Minutely, well, that would be 1 times 1 plus 1 over 525,600 to the 525,600. That one you should just know. If you've ever gone to the movie Rent or the play Rent, you would hear that in a song. Look it up if you're not sure. And then secondly would be 1 times 1 plus 1 over 31, let's see, 536,000. And so 31,536 and 3 zeros. So 31,536,000. So if you do these, well, here the first one, 1 plus 1 over 4 to the 4th power times 1, you are going to get a value of approximately 2.44. The second one, to the 12th or monthly, you will get a value of 2.6130. And stuff after it. For daily, you would get 2.71545, and more stuff after it. For hourly, it would be 2.718. 126 and change after that. For secondly, it is going to be 2.71827. And more after that. And for secondly, did I just say secondly? I meant minutely for that last one if I didn't. Anyway, for secondly, it would be 2.7182182.816, and so on and so forth. And then if we were to say infinitely, our equation would change to 1 times 1 plus 1 over infinity to the infinity power. Well, this is going to get you a number of approximately 2.7182818 and some other stuff after that. This value is similar in that it keeps going forever and ever, and so they assigned it the letter E, which is equal to that expression, 1 plus 1 over infinity to the infinity, and that is approximately equal to 2.71828 and all of that stuff. Now, there is a button on your calculator for E. You will find that button as the shift of the LN button. It is, oh, let's see, probably in the third row, right next to log, between log and sine on a Casio, and I do believe it's in the same place on a TI. Oh, I think it's on the left side on a TI. Anyway, look for that, and you should see that the shift of it is an E thing. And if you were to use the E, and just put in E to the first power, it would give you a value of 2.718281828. Well, understand that that goes on forever, and it just doesn't stop at that 8 at the end. But your calculator can only show you so many values. And so, infinitely compounding something means compounding continuously. Now, if you were investing money at a bank, they aren't going to give you compounding continuously interest. They might compound it quarterly or maybe monthly if you're lucky. But compounding continuously could be something like, oh, ants growing in your yard. So just remember the value of E is approximately 2.71828. Now, what can you do with that value of E? Well, you could do things like simplifying an expression, just like if you had variables. E to the 7th times E to the 3rd is the same as E to the 10th. And if you wanted to figure out what E to the 10th is, well, then you would just put in E to the 10th in your calculator and get 22,026.46579 and change. Here we have E to the 8th over E to the 22nd, which would be 1 over E to the 14th. Or you can say E to the negative 14 unless it tells you to have positive exponents. And so E to the 14th is 1,202,604, but because it's 1 over, we would have to flip that. And then you're going to get 0.000008315. But I think in your assignment you just have to simplify to something like that if you're given it. So then, how do you use it if you're dealing with something along this line? Investing $500 at 8% compounded continuously for 6 years, how much will you have? Well, if you set this up, it would be 500 times 1 plus 0.08 over infinity to the infinity times 6. Okay, well, can't do that. That's where E comes into play. And there used to be a shampoo of this kind back in the day. I don't even know if they still make it, but the formula is PERT, where P stands for the initial amount, E is E, R is your percent, and T is the time. So in this case, we would have 500 E to the 0.08 times 6. And so if we put that in, you have to make sure that you put the 0.08 times 6 in parentheses. You would have approximately $808.04 because it's 0.037 and things. And so that is how you set up an equation dealing with compounding continuously. Take your initial value, put it times e to the 0.08 times 6. Remember now this value is 2.71828 and so on and so forth. So that is greater than 1, which makes this an exponential growth function because that number is a positive number. And so now you will be working on an assignment from your worksheet. And let's see, that worksheet would be this one here. I think this is the one. Yes, it is. And so you are going to do this half of the worksheet, this half, and I want you to do the problems from the top all the way down and skip multiples of 3. And you may use the rest of the class period to work on that for this assignment. So that's from 17 to 80, skipping multiples of 3.